By the end of this video, you'll thoroughly understand what a RAG system is, and you'll have built your very own RAG AI agent, even if you're starting at the complete beginning without having to write a single line of code. So we are going to break all of it down, and I'm going to explain it as simple as I can. We are going to walk through the build step by step, and by the end, I think you're going to be really shocked at how much simpler this actually is. So without wasting any time, let's get straight into it. So just wanted to start with a quick definition of RAG, since it's probably a term you've been hearing quite a lot. So RAG stands for Retrieval-Augmented Generation. As the simplest way to think it is retrieving information in order to answer questions accurately. So if for example, imagine you're in a grocery store and you wanted to know where the flour is. You go up to the cashier or the person, the helper, and they check in the inventory and they tell you exactly it's in the aisle 6. So this is basically how working of the RAG is. And so when I say RAG agent, we're basically building an intelligent AI agent that has access to different data sources, so that when you ask it a question, it's able to look up the information, look up the right answer, and that provided the response to you. So I just want to clear that up, because I think a lot of people associating RAG with explicitly vector database, but that's definitely not the case. RAG just means getting more information to intelligently generate an answer. However, today we're going to build a RAG agent that works with a vector database. If you don't understand what a vector database is, don't worry. Here what it is. A vector database is a multidimensional space where we have different vectors everywhere, and those are all of the dots that you see right here. And all of these vectors represent different chunk of text, and they're placed in this space based on the meaning. So over here we have apple and banana. So all of the vectors are in this area, probably have to do with the word fruits. And then on the other side we have wolf, dog, and cat. So all of the vectors on this side of the vector database probably have to do with animals. And right here you can see a query coming through, that's kitten, and it's placed near the other animals. But I'll explain the whole query concept in the few slides later. So anyways, I said we are going to be setting up a vector database for our AI agent, and in order to do that, we need to set up two different things for this vector RAG. The first one is going to be a RAG pipeline, which basically just means we need to get data in our vector database. And the second part is going to be then actual RAG agent, whereas that when we can actually get to talk to the data in our vector database. So the first part what we are doing here is the RAG pipeline, and it's really simple. So let me break it down. So here's the visualization of RAG pipeline. We start off with a text document, and this is what we want to put inside our vector database. Then we have three things. We have to chunk it so that all the pieces get split into different chunks, and each of those chunks is what is going to be associated with one vector, one of these dot in the graph. After it's chunked, we run it through an embedding model, and this basically just means we are turning that text into a bunch of numbers, and then with those numbers, with those embeddings, we are able to vectorize the information, and that's how they get placed based on the meaning. So in this case, you can just pretend that the first top chunk has to do with the company information, and the middle chunk has to do with finances, and then the bottom chunk has to do with marketing. So that's why we are placed in different areas on this vector database. And we're going to be building a RAG pipeline and a RAG agent in a software called N8N, which is a no-code platform. And this is what it's going to end up looking like in N8N. So it's super simple, and we are going to be getting a document from a Google Drive, and then once we have it, we have to chunk, embed, and vectorize. So we are going to use this data loader to chunk it, this embeddings models to embed it, and this superbase node is vectorize and put it in our vector database. And as you can see, it's a really simple setup. It's only 5 different nodes, and no coding will be required. And now on the second part of the systems, our data is actually in the vector database, and we have to build an agent that can talk to it. So here's a visualization of how a RAG agent works, and it's a very simple process. So the agents get triggered when we make a query. So that's how it would start off. Let's say in this case, our query is what's company's mission statement. The agent then takes the query, and then it's basically going to send it off to the embeddings model to get embedded and turn into numbers. And we run it through same embedding models that we did earlier in the pipeline, so that everything is consistent and matches up. Once that query is embedded, it basically gets vectorized and placed in the vector database. And once you can see right here, because we asked about company X's mission statement, it gets placed near the other vector that had to do with the company information. From there, we pull back the company vector database, company vector, because it's close to this one. We pull back the actual query that was asked in the first place, and then the AI agent uses its AI brain to generate an answer for us. In this case, it's an LLM. So that's why back in this slide, we had the query equals kitten. That's how we know it got placed near the other animal related to vectors. So what is going to like when we get into N8N? As you can see, once again, not too difficult. We have a chat trigger here, and this is how we can talk to the agent, and we trigger it with a query. From there, the agent takes our query and it has to send it to the embeddings model to get embedded. After that, it's going to send it back to the superbase to be vectorized. The agent's then going to look at our original query, the vectorized information, and then it's going to use its brain to generate an answer for us. And for this specific use case, the document we are going to vectorize is a 22-page PDF going over the rules of golf. So once again, this process is we are going to chunk up the document, we are going to embed it and vectorize it, and that's how it gets into our vector database. And once we have all this information in the vector database, we can talk to it through our AI agent. So that's the example we are going to build out today together. But just so we can zoom out real quick, the actual data source for the vector database does not always have to be a text-based document. And that way that we can talk to our agent doesn't always have to be a chat trigger. Data sources should be whatever you want. It could be whenever a new record in a new ticket in HubSpot is submitted, we turn that into a vector. Could be an Airtable ticker, and it could be every single email we get, and we want to put that into our vector database. There's ton of different use cases. Same thing with the agent trigger. It could be something where the agent only works when you talk to it. We send it like a text message, we can link it up to Slack. Or it could also be okay, whenever I get an email, I want the agent to read the email, look up information in my vector database, and then respond for me. Or it could be every morning the agent's going to go off, look in the vector database, and send me some sort of memory. Or the other agent could also be triggered on something like a form submission. So there's a lot of ways that you can make it in RAG and RAG agents into whatever sort of flow you're looking to automate. And finally, just wanted to touch on real quick the different providers for vector database, and they all kind of have their own strengths and weakness. What we are going with today is Superbase, and I'm not going to dive too deep into exactly what it is. And for the memory, we are going to use PostgreSQL for a short-term memory. So I'll show you guys all of this. Let's go over to N8N and get set up. All right, so here we are at superbase.com, and if you haven't set this up before, don't worry. We're going to walk through that together. What I'm going to do is just click right here on the green button that says start your project. You can see that I am already a project set up. What I'm going to do is just go ahead and create a new one for the case of this video. I'm going to be able to spin up for this one for free. I'm just going to call this one test, and then I need to give myself a database password. So I've given myself a password, and don't forget this password, because we're obviously going to have this use in the later to connect to N8N and to our Superbase. All right, so right now you can see our project is going to be spinning up right now, and this will eventually go green. So while we're waiting for this to get set up, let's hop over to N8N and create a new workflow in order for us to start with this whole rack pipeline. So like I told you guys, what we're going to be putting in our vector database today is the 22 pages PDF that's in my Google Drive. Real quick guys, I figured out that it would be better experience to go through this video using the same exact PDF that I've got right here. So you can just follow everything I'm doing step by step. I'll have a link to this PDF in the description below. So in order for us to access the PDF, we are going to have it connect to Google Drive and end it in. So what I'm going to do real quick is hit tab. I'm going to type in Google Drive, click on that, and then I'm going to open up the actions, which is going to be a download file. Now that I'm on this node, all I have to do is connect to my Google account. If you do not know how to do that, or you haven't set up that, you can check out this video right here. It'll take like 3 minutes. Once you finish that and you are connected to your Google Drive, all you're going to do is look through our list of documents in our account. And ours was called rules of golf. So I'll type in rule, and we should it see it pop here, which you should see it pop here. Now I'm going to be able to pull in this PDF. So if I hit execute step, we should be able to see it come on the right hand side. And here it is. It's in our binary data, which is our rules of golf PDF. And what you'll also notice is when you run this node, it automatically added this when clicking execute workflow ticker, which basically means whenever I click this button down here, it's going to run the rest of the nodes that we have linked up. So we have our PDF right here, and all we have to do is next is to actually put it into the Superbase. So it's going to be super easy, super simple. I'm going to click on this plus button after the Google Drive. I'm going to type in Superbase, and we can see how we have Superbase, and this is where we have like our relational tables and stuff. But what we want to do is access a vector store. So I'm going to click on Superbase vector store, and I'm going to click on add documents. After clicking add documents to vector store, now what we're going to have to do is set up our Superbase credential, and also in Superbase create a database table. So in order to create our Superbase credential, I'm going to open up this drop down and click on create new credential. And what is asked us for is a host and a service role secret. So all I have to do is go back into Supabase. You can see our project status is green, everything is healthy. And on this left hand side, I'm going to go all over the way down to settings. In here, I'm going to scroll all the way down on the left hand side to data API. And then right here, the project URL is actually our host. So click on copy. We'll go back into the edit and we will paste the host right here. And then in order to get a service role secret, we are going to back into Supabase. I'm going to click on this left hand side right here where it says API keys, and then this button right here says right here service role secret. You'll hit reveal, you'll copy it, then you'll have to paste it into the section. So I just copy that key, paste it, and now if I hit the save, we should be connected to our Supabase account. And then it's always best practice to name that credential either your email or the date, just to keep track of time. So we've officially connected to Supabase. Now that we need to do is set up a table. If I click into here, you can see that there's no tables in our account. This may seem technical, but it's going to be super easy. Stay with me. You're just going to click on this docs right here. You're going to scroll a little bit down where there is a quick start for setting up your vector store. Then once we get into this page, all we have to do is scroll down a little bit and copy this SQL command right here. Go back into your Supabase, and on the left hand side we're going to see the SQL editor. Once this opens up, we're just going to click on a new SQL snippet, paste that in there, don't have to change anything, and then hit run. And this is basically going to be create a vector database for us called documents. If you already run this command before, you want to create a different database table, all you will have to do is get rid of the first two lines and say create extension vector database. You've already created the extension, and then right here where it says create table documents, you'll have to change that name. Instead of documents, you'll have to put in the name that you want for your table, and then you'll have to change every instance from there. But now, if I go on the left side and go to the table editor, you can see that we have a table right here called documents, and it's waiting for us to put in our vectors. So back into N10, I can open this up, and we should see if we just refresh the list. Maybe we should see our table right here called documents. And I don't want to confuse you guys, so if you followed all the steps I just did, you don't have to worry about this. But if you did create a different table, you create a table called test. You just make sure you change this right here to match the test rather than the match documents. And now that we have connected here, we just have to do two more things. We have to chunk and then embed so we can actually vectorize. The first thing we're going to do is chunk. And in order to do that, we're going to click on this plus right here under document. This is going to open up some document loaders for us, and I'm going to choose default data loader. Now what's happening right here is just basically telling a Supabase here what I want to vectorize, and here's what I want you to chunk it up. And the good news is we can basically just leave the text splitting as it is. So it splits up every 1,000 characters with 200 characters of overlap. If you wanted to go more custom, you can change it to 500 characters or 2,000 characters, whatever you want. But right now, we're just going to keep it simple. And then one more thing that is kind of tricky is we have to tell it what document to look at. It's actually embedded, and it's set by default to JSON. And we can't do that because our PDF is actually right here and it says it's stored in binary. So we want to change that type of data to binary. Now we should be all set up when it comes to loading data and chunking. So now that we have a chunking setup, we just need to connect our embeddings model. So I'm going to click on the plus button right here. I'm going to click on embeddings OpenAI. And if you don't have OpenAI account, all you have to do is click a or create new credential and just need an API key. You can just top it off using a $5 top up, and you will get your API key. So what you have to do is go to OpenAI in order to make an account. This is different than just having a ChatGPT plan or ChatGPT Go or even a Plus plan, because you'll have to add billing information to your OpenAI account. And once you get there, you'll just go to your dashboard. You'll click on API keys and you'll create a new API key. And all you have to do is copy that key and then you will paste it right here, and then you'll be connected. And now all we have to do is choose model text embedding 3 small. If you followed all my steps, you should be good to go. But if you did set up a vector database with different dimension, you'll have to make sure those line up right here. Okay, so everything looks like it should be set up. I'm going to hit the play button above our vector space, and what it's going to do is chunking, it's embedding, and now finally it's vectorizing just like we saw earlier on that video. And whatever you can see in that video, we got 77 vectors. So that 22 page of that we are looking at right here, it ended up splitting and chunking into 77 different vectors. So if I go into Supabase table and we give this a second, there we go. We should have 77 rows of information about the rules of golf. And if you want to see the data that's actually in each vector, you would look at this column called content. And if I open this up, you can see here's the final vector. You can start the game with the ground and hit the ball until it's end up in the hole, blah blah blah. So here's the first vector. Here's a tenth vector, and then Here is, the first 41st vector. In this column we have metadata, and then in this column we have actual numerical representation, which is our embedding. So we have our data in here, which was the first step. That was a rack pipeline. Now let's head back into N8 and let's create an AI agent that actually can talk to the information right here in our Supabase. So what I'm going to do is hit tab, and I'm going to type in AI agent and grab that AI agent right here. Now, as you talked about, the way we want to trigger this agent is just through a conversation. So I'm going to grab a chat trigger, which is right here, and then all I have to do is hook up this chat trigger right into the front of the agent, and now it will be able to get our messages when you talk to it. Now we need to connect our brain to our AI agent. So if I click on the plus under the chat model, I'm going to scroll down and grab here OpenAI chat model. Just because if you are setting up all this for the first time, you already know how to get there, and you get your API key, and you already have that credential set up. Or you can also use a free model like Gemini for this use case. But for my comfortability, I'm going to use OpenAI. And now we just need to choose a model to use. I'm going to stick with GPT 4.1 mini. It's a overall best all rounder. And now our AI agent has a brain. And the final step is just to give it a tool so that it can actually look into this vector database. So we're going to click on tool. We are going to type in Supabase vector store. The operations already set to retrieve documents as a tool for a agent. Description that I'm going to give for this tool is look up all the rules of golf. So this is just telling me that the agent, what this tool does is when to use it. And then once again, we just have to choose the right table to look through, which in our case is called documents. And then the limit is basically how many vectors do you want it actually to pull back. Right now we'll just stick with 4. And then the last thing we have to do is actually connect our embeddings model, because as you guys see, the query has to be embedded as well. And something that's really simple is we already have an embeddings model set up down here, so you can just drag and connect to that. So without even giving our agent any sort of instruction or system prompt, let's test this and see how it works. All right all right so here we are in the PDF about the rules of golf, and what I'm going to do is just ask it basically about the practice rules. So I'm just going to say, what am I going to do? What am I allowed to do for practice? Let's see if the AI understands that we are talking about the golf and that it needs to use a supervised vector store, which it did, and now it's going to take the information and return an answer to us. And then we'll basically validate if it's correct or not. So right here we get an answer. According to the rules of God, practice before or between rounds, you can practice blah blah blah. And if you go over to the PDF, you can see that pretty much exactly word by word what we're looking for. And just so you guys what actually happened behind the scenes, you can click in the agent and you can click on the logs, and this will show us exactly what just happened. So the human asked the AI agent, "What am I allowed to do for practices?" And that's what triggered the workflow. The agent uses a Supabase vector store and sends off the query practice rules in the golf, and then this gets embedded using the embeddings model right here. And then what we get back after that gets embedded is the answer, which is in these 4 different vectors, which is the actual content in the vector database. So when the AI agent will look at this context, it will think about the question it was asked in the first place, and it will actually give us an output, which is what we saw down here in the chat message section. So now that we've validated that the AI agent can look through the Supabase vector database, we have one issue, which is it has no memory. So we literally just asked it about the rules of golf, but it cannot retain the memory if we ask questions again and again. So the way we are going to set up the memory is we are going to use Postgres, because we've already set up our whole Supabase thing. So I'm going to click on the plus under memory right here, and you can see we could use a simple memory which would store everything in an ATN. But if you want to able to look to different interaction that we are having with the AI agent and store that in Supabase, what we're going to do is connect Postgres chat memory. So the first thing we actually have to do is connect our Postgres credential. So to set this up, set up this credential, I'm going to open up the drop down, click on create new credential, and you can see it's a little bit different than the original Supabase one. But just follow what I do, and you'll be all set. I'm going to go into Supabase, and at the top of the screen, you see there's a connect button. So I'm going to click on this connect, and I'm just going to scroll down a little bit where we have right here the transaction pooler. I'm going to click here, right, and view parameters, and then we just have to grab a few things from here. So the first one is going to be the host. I'm going to copy the host, and we're going to go back into N8N and just paste things in right here. The database I can leave as Postgres, because if you can see right here, the database is Postgres itself. But the user, we are going to copy this and go back and paste it right there. The password is going to be the password that's same that you've set up in the project earlier in this video for the Supabase. So let me type that in real quick. And then the last thing we need to do is the port. So if we go back into the screen, we can see right here we have the port. So all I have to do is come in here, paste that there, and if we have it safe, we should go green. Connection tested successfully. And so once we started chatting with our agent once again, it's going to store not only what we asked the agent, but it's also going to store the agent's response to us in a different table in Superbase. So let me chat with the agent, and then I'll show you guys that. So now if I'm talking to agent, I say, hello, my name is Azmi. We're going to send that off. It's going to check if we have talked to it before. It's now going to answer, as we can see that in our Supabase. There's going to be a new table right here. If I just refresh it real quick, called anytime chat histories. And if I click into that, it's basically going to have a human content. So every time we talk to it, it's going to store that here. And that is also going to store that AI agent's response to us every single time. So now if I come into the AI agent and say what's my name, it's going to look in the Postgres memory and then it would be able to answer, because it actually has a context window. Your name is Azmi. How can I help you today? Two things to keep in mind real quick. The first one is that in this Postgres memory, the context window is length is 5. So every time we talk to it, it's only going to remember the 5 most recent interaction. But you will have your own ability to change and adjust the context window length. But then the AI would just be processing more tokens, which is not healthy. But if you are using, like Gmail, or you are using text message or something, you could store the session ID as someone's email address or someone's phone number, and that's how agent there could actually retain all of that context within the individual person, with that individual person. Okay, so so now you've officially built your first RAG pipeline, where you got data into a vector database and build a RAG agent that can talk to the data in there as well. There's a lot of ways to expand of this as of system. I'd say that the next one would be creating it so a little bit more dynamic. You can work on this, build more stuff, tweak it here and there, and see what works best for you. You can try the trials that I've mentioned in the earlier video. You can set that up as well. And that's going to be all for this video. I hope you enjoyed the video and learned something new. I appreciate you guys for sticking around to the end, and I'll see you in the next one.